In this video, we are going to look at how to find the inverse of a 3 by 3 matrix. The steps to find the inverse of the 3 by 3 matrix are given below. Step 1. The first step while finding the inverse matrix is to check whether the given matrix is invertible. For this, we need to calculate the determinant of the given matrix. So if the determinant is not equal to 0, then it is an invertible matrix, otherwise not. Now, the word invertible matrix means that we can find the inverse of the matrix. Once a matrix, the determinant of a matrix is equal to 0, then it therefore means that it is a singular matrix, meaning that you cannot find the inverse of that word matrix. So if it is not equal to 0, you need to move to the next step, because the matrix is said to be invertible. That means you can find the inverse. Step 2, calculate the determinant of the 2 by 2 minor matrices. I'll show you how to do that with an example. We are going to get the 2 by 2 matrix minor for the given 3 by 3 matrix. Step 3, then we formulate a cofactor of the matrix. So we're going to use the minors of the matrix to formulate a cofactor. Step 4, we find the adjugate or the adjoint of the matrix by taking the transpose of the cofactor matrix. Step 5, we finally divide each term of the adjoint matrix by the determinant value of the given matrix. Okay, we are going to divide the adjoint of the matrix by the determinant value of the given matrix. Okay, now let us quickly take an example to illustrate these steps. So example, given that matrix A is equal to 1 2 3 0 1 4 5 6 0, find the inverse of matrix A. Solution. Step 1. So we're going to follow it step by step from the previous section. So we'll look at the steps on how to do this. So step 1, we're going to find the determinant of matrix A first. So we have to find the determinant. If the determinant is equal to 0, we do not need to proceed with the problem. But if it is a number, if the determinant is different from 0, it's not equal to 0, then we proceed to the next step, telling us that the matrix is an invertible matrix. It is not a singular matrix. So now we're going to write the matrix in this form. What you see here is called det A, or the determinant of A is equal to the given matrix. Notice that the matrix now is written with strokes, not with with braces, open brackets again. Okay, and also these are also written with braces. So we are going to look at how to determine the determinant of this matrix. Next, you are going to assign signs to the entries on the matrix. So we'll start with plus, minus, plus. If it continues, you go with minus. Then the next one have minus, plus, minus, plus, minus, plus, and so on. So this is the format in which you write the signs. So the next you have to do is to utilize either row or column that will help you minimize your simplification. So if you look at this rule here, this row 2, column 1, you find out that there is a 0 here, meaning that whatever you multiply by 0 is going to end up with 0. So it means that this portion here is going to help you minimize your work. Also, if you look at this again, row 3, column 3, you'll find out that there's 0 here. This can also help you minimize your work. Okay, so for the purpose of this class, I'm going to use row 2, column 1, this element in row 2, column 1. That's what I'm going to use to simplify my job. It's not necessary that you must start from here. You can use any of the columns or what rows. But for me, I feel that this will help me simplify my job more easily. So here you see I draw a line through there, then I cancel the other part. Okay, we are going to take note of the sign that is here. So the elements that are left are 2, 3, 6 and 0. So we are going to write that out. So det A is equal to minus 0, the minus that is here, and the element that fills the rows and the column. So minus 0 into the elements that are remaining 2, 3, 6 and 0. We have that here. So that, then we move to the next one. So the next one again, I'll draw another line. I'll cross that same row, then I'll cross the column, the next column. So the element that is there is 1 and the sign is plus. So we're going to have plus 1 and we're left with this element 1, 3, 5 and 0. So we have plus 1, 1, 3, 5 and 0. That's the elements that are left. Next, I'll cross the same row again. Then I'll now cross the third column. So the element that is there is 4 and the sign is minus. So I'm going to have minus 4 into, so I'm left with what? 1, 2, 5 and 6. Okay, we have that. Now take notice again that I did not use curly bracket, open brackets or braces, parentheses for what this. I also use what? Strokes for this. This is how to look for the determinant. Until you get to the determinant, you must always use these symbols to get what? The determinant. Next, notice that if I multiply this by 0, it's going to give me 0. So my result is going to be what? 0. So that is the essence of me using this row, and the element, the entry in this row and this column here to easily simplify my job. If I have used this, I also get the same result. So again, when I multiply 1 by this, I'm going to get this. So my matrix, my determinant will greatly be what? Simplified. Okay, so from here my determinant of my matrix A is going to be equal to 1350 minus 4 into 1256. Next, I have to simplify. So det A is going to be equal to 1 times 0 minus 5 times 3. Okay, then I have my minus 4, then into 1 times 6 minus 5 times 2. So we obtain this. Det A is going to be equal to 1 times 0 is 0 and 5 times minus 3 is minus 15 minus 4. Then we have 1 times 6 is 6. Then minus 5 times 2 is minus 10. So we have that A is equal to 0 minus 15 is 15 minus 4 times 6 minus 10 is minus 4. Okay, so this will be equal to minus 15 plus 16. That is minus times minus is plus, 4 times 4 is 16. So when we work this out, this is going to be equal to A. That A is equal to 1. Step 2, we find the determinant of a 2 by 2 minor matrices. So this is how we look at this. To find this, we write out the matrix again. The matrix A equals 1, 2, 3, 0, 1, 4, 5, 6, 0. These are the entries of the matrix. Again, we assign the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. Next, we are going to write the matrix. Okay. The cofactor matrix. The cofactor, this is the cofactor matrix. It's going to represent, it's represented by C11, C12, C13 down to C33. So these are the entries. So C11, C12, C13 up to C13 will give the will be the determinant of the minor matrices formed of the 2 by 2 minor matrices formed from the 3 by 3 what matrix. Okay, so here we are going to strike. So this time around I strike the first column and the first row. So you can see that the elements that are left are 1, 4, 6, 0. And take note of the sign. The sign is plus. So when we do that, we have C11 is plus 1, 4, 6, 0. So I use the method of looking for determinant to look 2 by 2 matrix determinant to look for it. So we have this times this minus, that's 1 times 0 minus 6 times 4. That's going to give us minus 24. So we are going to do that for all of this. Okay, then for C12 again, we strike out row column 2, row 1. So the elements that are left are 0, 4, 5, 0. And take note of the sign. The sign here is minus, so here is going to be minus, and we'll have this. Then when we work this out, we're going to get what? 20. So we have 0 times 0 minus 5 times 4. So that's going to give us 0 minus 20 times minus here, we get what? 20. So we do that again for column 3, row 1 again. Okay, so the elements that are left, when we strike out this and this, the elements are 0, 1, 5, 6. Then you work that out again, we'll get what? Minus 5. Okay, next we go to row 2, column 1. The elements that are left, the element there is 0 and the sign is minus. So we have 2, 3, 6, 0 left. So that's why we have this here. Again, when you multiply this by this and subtract it from the product of this and this, you obtain what? 18. Next, we strike the same row again and the next column 2. So the elements that are left are 1, 3, 5, 0, and the sign is plus. So you must always take note of the sign. It's very important. So we'll have this. So when you do work this out, you're going to get what? Minus 15. Next, the same row 2, column 3. So we are left with 1, 2, 5, 6, and the sign is minus. So we have this. So working this out again, you're going to get what? 4. Next, we go to row 3, column 1. The elements that are left are 2, 3, 1, 4, and take note of the sign. The sign is plus. So we'll have this. When you work this out, you're going to obtain what? 5. Next, row 2, 3, column 2. The elements that are left are 1, 3, 0, 4. Take note of the sign. The sign is what? Minus. So when you work this out all out again, the way you look for determinant, you get what? Minus 4. Next, row 3, column 3. So the elements that are left are 1, 2, 0, 1. And take note of the sign. The sign is plus. So you have plus. So when you work this out, the result is going to be what? Equal to what? 1. And the next you have to do is to fix each of these number: minus 24, 20, minus 5, 18, minus 15, 4, 5, minus 4, 1 into all of this. So C11 is minus 24, C12 is 20, C13 is minus 5, C21 is 18, C22 is minus 15, C23 is 4, C31 is 5, C32 is minus 4, C33 is 1. So we're going to replace all of this with this here. So step 3, we formulate the cofactor matrix. So I have explained that this is the cofactor matrix. So that's what we want to establish now. So that's the cofactor matrix. So you can see that each of these numbers here represents all of this here. So that gives us the cofactor what? Matrix. So now next we're going to use this now to work on this. So we'll go to step 4. Step 4, we're going to find the adjugate or the adjoint of the matrix by taking the transpose of the cofactor what matrix. So this is the cofactor matrix. We are going to take the transpose of this cofactor matrix. So adjoint A is equal to the C transpose. Okay, this is the symbol for C transpose. I know you're familiar with this. So therefore C transpose is this. You just take the row, this row here, make them to become what the first column. The second row becomes the second column, and the third row becomes the the third what column. So just interchange rows for column and columns for what row. That gives you what the transpose. Step 5. We now divide each term of the adjoint matrix by the determinant value of the given what matrix. So we are going to divide the adjoint A to get the inverse. We are going to divide adjoint A by the determinant of what A. So A inverse is equal to adjoint A divided by what A determinant of what A. Okay, so this is going to be A inverse is equal to 1 divided by 1, because our determinant we calculated from the first step is 1. So we just put 1 over 1 divided by this, then multiply it by this matrix here. So that gives us this. Okay, remember that the adjoint of this matrix, of the matrix A, is the transpose of what this matrix here, which is this. Okay, so when you divide 1 by 1, that's going to give you 1. So what you have to do is to divide all the term here by 1. Now remember that this matrix, this is just 1. Any number divided by 1 will give you 1. So it will return this matrix here again. So you divide minus 24 by 1, that's going to give us minus 24. 18 divided by 1, that's going to give us 18. Divide 5 by 1, that's going to give us 5, and so on and so on until you get to what this. So it therefore means that A inverse is going to be what minus 24, 18, 5, 20, minus 5, minus 4, minus 15, minus 4, minus 5, 4, and 1. So this is the inverse of matrix what A. Okay, so I hope with this explanation you will be able to understand how to calculate how to find the inverse of a 3 by 3 matrix.